In this video, we are actually now focusing on the knapsack problem, okay, and get to understand what this problem is all about. The knapsack problem. Okay, so what do you need to know about the knapsack problem? Well, the knapsack problem is somewhat a topic that applies maximization of resources. So usually what happens is that you would be given a certain budget, okay, that you have to live by, or it's either you would get you would have the exact budget used up or something lesser. So for example, maybe your budget is 5. So we're saying we're maximizing a budget. It's about trying to maximize the best items that you can mix, okay, and combine to maximize your resources. So it can either be less than 5 or but equal to that particular 5 in such an example, for example, right? So now when you're solving a knapsack problem, first of all, you need to know how to calculate what they call the benefits, and then you would rank these particular items. Benefits and rank. Yeah, then I'll talk about rank very soon. That's why it's more straightforward. Benefit, it's about basically it's this fraction that denotes the coefficient in the objective function, okay, over the coefficient in the constraint. Let's take this example and we'll understand this formula. So suppose they told you that, okay, z is equal to 3x1 plus 2x2, right? Okay, then they've given you one just a constraint, for example, subject to 4x1 plus 5x2 less than but equal to maybe 10, as an example. Then they tell you find the benefit. Of course, okay, they won't really tell you, but when you're starting an knapsack problem, you need to find what they call the benefit. So what you do on benefit, I was saying coefficient in the objective, right, over coefficient in the constraint. What's the constraint? The constraint is the one where they subject to. How about in the objective? The objective is the one having z. Now what you'll be doing, we said the coefficient in the objective and then the coefficient in the in the constraint, so they should be corresponding. Like since 3 is the coefficient in the objective and has what variable? x1, right? Therefore the corresponding coefficient in the constraint is this one below here, the 4. So they have to have corresponding variables. That's the only way it would make sense when you're finding the benefit. So the coefficient in the objective, of course, corresponding with the coefficient in the constraint. So I mean, so even had to do the other benefit, you'll be like, okay, 2 has x2 there, right, corresponding with what? With 5. Then you'll be finding the benefit. So like for example, in our first scenario, benefit would be 3/4. Just leave it like that as a fraction. Do not really compute as such. We just, okay, we leave it as a fraction most of the time, because the formula said it's c over ai. Remember this, coefficient in the objective over coefficient in the what's this, your constraint. Okay, then the other one was it 2/5. Yeah, something like that. You've done your benefits. Then when you're ranking now, how do you rank? Ranking, first of all, if you divide 3/4, what answer are you getting? Is it 0.75, right? Okay, when you're ranking, you want to know first of all the which of these has the highest value. So 2/5 is what? Is it 0.4, right? Yeah. So in your ranking, you want to know first the values of each, so that you can know the highest is on you rank number 1. That's usually how it is. That's why when you're in the benefits column, just leave these fractions I left for you. This is how you're presenting your work in the test. Remember this. Then now on the ranking part, put the actual values of these. Like 3 into 4 is what? It's 0.7. 2/5 is what? It's 0.4. I hope I'm moving together there. Then the ranking is about highest, on the highest particular figure is your ranked number 1. We just know that, okay, this will be number 1, this will be number 2, something like that. Yeah, so just know your column should just look like that. Okay, we just put item. Okay, here is okay. Now we had 2 items because we only had like x1 and x2. That's what we mean by 2 items. If there was x3, we would have had 3 items. So here we just had 2 items. Then there'll be a column for what? The benefit, right? Okay, I'll just be abbreviating, sorry for that. Okay, then just finish it. Benefit, we've had the first one gave us 3/4. Item number 2 gave us 2/5. Rank, in the rank column, what do you put? I was saying you put the actual values. This is just how you present information. Then you in your head just know that the highest one is ranked number 1. As you'll be beginning your knapsack problem. So let's look at an example to make sense out of all this. But please remember, when you've accepted a particular item, because you know you'll be putting them up to a certain, you have a certain budget, and then now you'll be picking items based on their ranks. Okay, the one the highest rank is chosen first. Just remember that. So it's like when you've accepted a certain item, we denote it by 1. Okay, 1 means acceptance. Okay, when maybe our x value is 0, then we have declined. It's about accepting or declining. Remember this part. So 1 is acceptance, this one is to decline. Just remember this. These are the points. So let's begin a question and actually solve it and see how the branch and bound will work out. Let's read this question. The 3 most popular items in China that are not considered security risks by the police are denim jeans, radio, tape cassette players, and tape cassettes of popular rock groups. The black market profits and weights for each of these items are shown in the table below. So you have your table, right? Weights of particular items, and then their profits. So you would have to make a function from this, like the way I gave in my example. You need to work with functions. That's the only way it will help you solve this knapsack problem. And then now they're saying, okay, the objective of the traveler is to determine the combination of items to put in the duffel bag that will maximize the total return from the black market without exceeding 5 kg limit. Failure to adhere to the 5 kg limit will result in revocation of the travel limit. Solve this knapsack problem using branch and bound. Okay, we'll use branch and bound, and I'll explain as we move. Okay, very similar to that video I've earlier shared in integer programming. If you do check it out, you would understand branch and bound further from there as well. But here to be like, we'll still be referring to it again. So let's solve this. First of all, I said make equations first of all from your given info. So remember what I told you when you're starting a knapsack problem. Make that small table showing item, benefit, okay, and rank. Please, this is very key when you're starting. Then of course the equations as well. So maybe I would say equations first, then the table of rank, benefit, and the like. Then we start the branch and bound process. So remember, on profit there are these figures, right? Denim jeans, the radio cassettes, and the like. So you can make maybe item 1, which was called, is it the same jeans, right? You make that x1, like we're just putting those variables that we normally use. Okay, then the second item can be x2, the third item can be x3. Then the profit that you're seeing there that we're mentioning, this can be like your profit function, okay, or your objective if you want, because usually what guides you to put an objective function is where you'd see the words profit, because that's what you're trying to maximize. Yeah, so this is how the equation will look. 90 x1 plus 150 x2, which will be now plus as well 30x3. Done. That's your objective input Z. Already these are marks, by the way. Subject to, well, the genes were given in form of weights. Okay, the weights are what is maximizing this profit. If anything, those weights, that column for weights, if you rewind the video, you would find this. You would find there was 4, 3, and 1 in this order. It's 4, 3, 1. That's the order we're following. So the first number will be x1, 4x1. The second number 3x2. Yeah, we're just making the constraint now, because we've done the objective. What's left here? What's left is the constraint now. 4, 3, and 1, which is just x. Yeah. What is the budget? 5 kilograms. Maximization takes what sign? Less than but equal to. Remember that. That's just one part. You can even get some marks already here. Then go to the table showing rank and benefit. Remember, benefit is what? The coefficient in the objective over the coefficient in the constraint, but they should be corresponding in terms of the variables. You don't just mix them up. So 90 will go with 4, 150 will go with 3, 30 will go with 1. Yeah, so let's do that quickly. So we're in that table. Okay, item, we have 3 items. Item number 1, benefits. We have 90 over 4, the first item. 90 over 4. The next one, 150 over 3. The third, 30 over 1, which is as good as saying what? Because 30 over 1 is as good as 3. It's there. You're now in your rank there. So in the rank, we just put the values that is 30, this is 50, that is 22.5. You can just test those figures as well so that you're following through. After this, you want to start your knapsack problem, solving it via what? Branch and bound, and I'll be explaining. So first of all, which item will start? I said you pick the one with the highest what? Highest rank. Is the one which you choose first, in short, when you're doing your knapsack problem. Start with the item having the highest rank. In this case, it will be item number 2. That's the one which will, that is like it will get the first priority in terms of choosing it. That's what we mean. Then others will follow based on whatever will be left in the budget, something like that. So let's do that now. We solve this. Well, a branch has no one way of drawing it, like the fashion. You can put an oval shape or a box, something like that. So I'll go with the oval shape. So you have 3 products. X, which we're calling, of course, X1 is item 1, X2 is item 2, X what? X3 is item 3. Now we said we're choosing them according to the what's this? Their ranks, and item 2 had the highest rank based on the value it had. So remember your budget, it's there. You have, this is you are maximizing via this constraint which we made here. Please remember this, equal to 5, greater than but equal to 5. So x2, okay, let me just put in the table x2. I have to write that well. X2, we said we're choosing, if you accept, it's 1, you put 1. That's what you should remember. When you deny, it's 0. It's either acceptance or refusal. That's how it is here. So the item that gets the first choice is what? The one with the highest rank. So item 2, you accept. You even put 1. That's what you're just going to be showing, acceptance or denial. That's all. Then, meaning that item 2, check on the constraint function, right? What value was it? It had 3, right? This shows you that out of a maximum budget of 5, you have taken out 3. That's how you interpret these things. The coefficient of that item you have chosen is what you get to subtract from the amount that you're trying to maximize, leaving you with what? With 2 kilograms left. What item will come next? The item that was now second ranked after this was item 3. So x3. Can x3 fit in a 2 kg bucket, in a 2 kg budget? Look at x3 has 1 as a coefficient and you are left with 2. It can actually fit, right? So you can just say accept all of it. Okay, even put 1. How about the next item? You've got 1 kilogram left. Remember you are on 2, you've just put in 1 for x3, you're left with 1 kilogram. The other item has 4, it needs 4. Look at this, it needs 4, and you're left with 1. What do? Just get the quote, you just get a fraction, because what you're doing is you're maximizing a budget, so you finish up all your resources. So this one is just going to, you're just going to get a quarter of the 4 that is needed, but just get a quarter. That's how you usually solve these questions. Then from this branch, you know branch and bound requires that to continue branching, you're only branching numbers that are what? Non-integers. Okay, in this particular branch that I've drawn or circle, do we have a non-integer? Yes, we do. X1 as a non-integer, that fraction 1/4, because an integer is a whole number. Let's remember this. So I do advise you watch that video, integer programming, on my channel. Yeah, so an integer is a whole number, it's not a decimal. So once you see a decimal, that will call for further branching, because we only branch off numbers that are non-integers to see and find an optimal solution which will just have integers. So what will come and branch off here will be x1. We've indicated, okay, it's x1 we're branching, and x1, because the branch has 2 branches, it's supposed to have 2 branches. Yeah, then you ask yourself, 1/4 is 0.25, right? What are the 2 bounds that are between this number that are integers? It's 0 and 1, right? Okay, so there will be 0 here, there will be 1 the other side. So here, what sign do you use here? Are you supposed to use less than but equal to, greater than but equal to on the branches? Well, in a knapsack problem, as we said, it's either it's equal to something or it's just not there. So it's either it's just equal, that's all. Because you know what you're just trying to do is that it's either what, when x is equal to 0, it's either you've denied, period, nothing like greater or equal to, but you just denied that it's just equal to 0. So then they just use the equal sign on the branches. Remember that. Even this side is either x1 is equal to 1. So I'll rewrite this, don't worry, and show you what I'm trying to say. Then now, this is what you do. Remember, we have just branched from that first one we had there. x1 is equal to 0, okay, because these are the bounds of the 0.25. There was between 0.2, the bounds between on 0.25 are 0 and 1, huh? Integers. You're just looking for integers which are within that number, and on the upper side and the lower. So we said we just use equal sign because it's either equal to this, or it's either they've just said no, nothing like greater or whatever. That's the reason why. Then you branch, you start making another branch there, start picking the items again. According to this branch which has x1 is equal to 0, this should tell you something, okay? A branch which has x1 is equal to 0 means that item 1 has already been rejected. Please, let's be clear on that one. According to this branch which has x1 is equal to 0, meaning item 1 has already been rejected, and thus the budget is still equal to 5 kilos and nothing has yet changed. Then now, start the selection process again. Huh? Which one was ranked number 1? Item number 2, right? Remember its value. It had in that I'll always keep writing this constraint: 4x1 plus 3x2 plus x3. Now item 2, we said just got a coefficient of 3. The budget is 5. We are on 2 again, right? So you're left with 2 kgs again. So if once it's within the budget, we just accept, we even put a 1. Then the last one, x3. So x3 there will be like when you're now looking at x3, it has 1, right? Okay, it's 1 there. It's within the budget. Okay, very much within. So 1. You'll be like, oh, this looks feasible, right? This particular branch, you look at it, it does look very feasible because x1 is 0, item x2 just entered directly, item x3 there as well. Okay, this one also came out well. That's 1, and then you even have like a 1 extra kilogram to spare, right? So what you're deducting, remember, is these coefficients which are in the constraint, because they are the ones that affect that budget that you have as a total of figure of 5 there. Then just try the other branch, but when they're all integers, you even know something positive is that you're doing the right thing. And when you find all integers, usually that's when branch and bound stops. Yeah. Then try this other branch when x1 is equal to 1, right? Let's start when x1 is equal to 1, meaning you have accepted item x1 here. That's what this means. You even put a 1, assign a 1 immediately. Then on the remaining 2, you follow rank still more because you want to know which one you choose on the remaining 2, since x1 has been accepted according to the branch. On the remaining 2, you have x2, which still has the highest rank. Your budget is what? Remember, if you have accepted x1, meaning your budget has obviously reduced, right? If you are initially on 5, what number are you on now? x1, item 1 has 4 as the coefficient. So if your budget is 5 minus that, it's 1 left, right? Therefore, if you want to now incapacitate item 2 according to the 2 that are left, and you pick item 2 because that's in terms of the rank, yeah, you have 1 left and you need 3 kilos of item 2, right? Then you just need the fraction in that case, because like in that case it's not necessarily going to be the whole thing, but we just want to maximize, so we finish up in that 1 kg that's there. Then therefore item x3 is what? Rejected. Why? The budget is complete, it cannot join us. You even put 0. Take note, one branch is not done. What you just do, if you have such a scenario, just test the other branch if it can take you any further. It's just a matter of testing, yeah? Okay? Otherwise, one side has shown that this is a possible solution. Please, should you be pausing and taking note of these things as we try to finish off this other branch which has a non-integer. How do we identify a non-integer? A number that is a decimal. Just know that it's not a whole number. That's a non-integer. So let's do that and finish off this branch if it can even improve any better. So please remember that this time around it was item x2, that was the non-integer. If you rewind in the video, it gave us like 1/3, right? So that non-integer is the one you branch off. The rules are still the same. So you'll be like, okay, x2 and x2 this side, right? Then assign something. What are the bounds? 1/3 is as good as a recurring 0.33, right? Meaning the bounds between that number on the higher and the lower side will be what? 0 and 1. So x2 is either equal to 0 or equal to 1. Remember, the branches have just equal signs in a knapsack problem. It's different from normal integer where we put those greater than and what, but in a knapsack it's always equal to something. Then start finding the new values again. So in a branch where x2 has shown that it's equal to 0, meaning automatically it will not be accepted. Please let's remember that. So x2 will be 0. What about the remaining items? There's x1 and x3 which are needed to be put here. Which one do you pick first? Remember your table of benefits there, right? And the values that were being found in rank. Between x1 and x3, which one had a higher rank? Well, x3, if you remember, it had 30, and then x2 at 22.5, meaning go for x3 first, and then of course, yeah. So remember, your budget is on 5, and you're on a branch that has x2 is equal to 0, meaning nothing has been touched because you've rejected. Just look at it in that realistic way. So you're now looking at x1 and x. We said we'll go for x3 because it's got a higher rank. And what was its coefficient in that that equation, the subject 2 there? Well, the coefficient of x3 was just 1 in that constraint. So it's like 5 minus 1 gives you what? 4. I hope we're moving together, meaning item x3 is very much within the budget you've been allocated. Item x1 now can finally join us. It requires 4 kilos in that, so it requires 4 according to that constraint. And how much are you left with? 4. Therefore, it's equally within your budget. We'll be like, okay, we found another integer branch, right? Remember, there is one we left. If you rewind the video, there's one we left, which was also looking very feasible because it had all integers. Even these are also integers because integers are just whole numbers, okay? Yeah, okay. It's a possible one. We'll come test both of them and I'll tell you which one you go for as your optimal solution. Next, x2. When x2 is 1, let's do that. When x2 is 1, it's like you have accepted. Remember, 1 means acceptance, and if you accept, your budget cannot actually remain the same in that case. So if you had 5 initially and x2 had what value in the circle, the constraint, it had 3, right? So it's like 5 minus 3 giving you what? Giving you 2. Okay, that's what that means, meaning that if you have accepted x2, you're already left with 2 kilos already. Yeah? Then you have x3 left, you have x1 left. Which one goes first? Okay, x3 again gets a priority because it's larger in terms of rank. So they have 2 kgs left. x3 requires 1. Very much within. Okay, very much within. Okay, you are left with a kg. Yeah, I hope we're subtracting your iron 2 minus 1. You're left with now. You're now left with like a kilo, and x1 requires 4 according to that particular constraint there. So it's like yeah, so I was saying like x1, according to that constraint, was like 4x1 and the like, and it requires 4, but there's only 1 kg left in the budget, so just put a quarter. And then this has taken us back to like what we had at the start, right? So this is how we know that if something takes you back to where you started from, like a solution looks very similar, just know you should stop. You cannot improve the problem any further. You just stop. And yeah, we'll just end there and test. Let's just test those two which are already integers, because our end game is to find a branch having integers, and then we get to test which one will have the maximum z value. So I want to erase this, and I hope you've been following. We had the first branch which came out as x1 was 0, x2 was 1, and x3 was 1. Initially, before we even reached at the end, we had this branch. Test its z. Well, z, the objective was like 90 x1, so it's like 90 times 0 plus 150 times 1, okay, plus 30 by 1. What does this give you? 180 for your z. Test the other one which we produced at the end, which was it 1 0 something? X1 was 1, x2 was 0, x3 was 1, right? Test the z also here. X1 we had 19 here in the objective. X2 we've made it 0, so it's like 150 by 0, then 30 by 1, therefore 120, right? Remember, we're maximizing. Which z do you go for? Therefore we go for the largest z, which was z of 180. Of course our x1 was 0, okay? Let me just rewrite this. Z was 180, x1 was 0, x2 was 1. These are the answers that you write for this. X2 is 1 there. Just rewrite this part. X2 is 1, x3 is 1. That's your optimal solution. We're maximizing, go for the largest z. Even though there were many integers that came up, go for the largest. And basically this is how you handle a knapsack problem.